Hello everybody, you're very welcome back to the channel. So as you can see from the thumbnail, this video is all about alternators. So alternators, how they work, what they do, what can go wrong with them, and how we can fix them. This will be the next video in the line of videos that we have done. So we've already done one on the battery, we've done one on relays, we've done one on the starter motor, how they operate, and basically a similar video to this. So if you haven't seen any of those videos, I do suggest that you do go back and take a good look at them, because it all ties in. It's all the one. But today, as I said, we're talking about the humble alternator, small or not so small. They all come in various different shapes and sizes and different outputs for different systems and different applications, from small cars to larger tractors, larger machinery that would have a huge need for, electrical outputs for lights and stuff like that for operating at night time. Although modern machinery now obviously have a lot of LED lights, which are a hell of a lot less hungry for power, I suppose, when it comes to the electrical end of the system. So yeah, we're going to dive straight into it. There's going to be no messing about. So sit back, relax, and enjoy this little video. So we're going to start with the unit itself. So this is an alternator. It's an IC alternator, so it's got an integrated regulator built in, 12 volt. It's a Denso, and this alternator has an output, I believe, of 65 amps. Now it generally is marked on them. It's marked on the label, the output, but it's not marked on this one. If you do look up the part number, it will give you the output of it. So we can tell straight away that this is off something that would have a low enough power demand. So something that doesn't have a lot of lights, doesn't have a lot of too much electronics on it or electrics on it, because modern alternators today will run up to somewhere in around over 200 amps. This one I believe is about 65, so it's a small enough one, and it is off a machine. So if anyone can guess what machine it's off, I'll give you a little hint. It is a machine that is built in Ireland. So if anyone can guess what machine it's off, yeah. So what can go wrong with them? Look, at the main thing to start with is the belt. So the belt that drives the alternator, so in this case it's a V belt, so it's shaped like a V down inside in the pulley. Some have a micro belt that drives them, that has multiple ribs on it, multiple ribs on the belt. Some have automatic tensioners, some have manual tensioners, some have no tensioners at all, and they are fitted with what's called a stretchy belt. So the belt stretches on over it and there's no tensioner on it. Belts give trouble, tensioners give trouble. In this case, the pulley won't give trouble because it is a fixed pulley, but on a lot of more modern alternators, you would have what's called a decoupling pulley, or a pulley with a clutch in it. And that's basically to, because the output of the higher alternators, up on 200 amps, there's a huge amount of torque being created or needed to drive it, because of the magnetic field that's actually built up inside in the alternator. And what will happen is it'll cause the belt and the system to vibrate. So it needs a clutch built into it to allow the sort of a freewheel of the clutch when it's under load, to prevent a sharp jerking when it's when systems are being turned on and off inside in the vehicle. And those pulleys do give trouble. They lock up, the freewheel clutches lock up in them and they don't operate. And what you get then is a shaking of the you can feel a shaking of the engine or shaking of the tensioner if you look down on it. So the first thing we need to do when we're checking them is we take the belt off and we'll check to see, is there free play in one way or the other. It should be locked up in one way and free play in the other, but this particular alternator doesn't have that, so that is not going to be a trouble. After that, then what else can go wrong? So you'll hear a growling out of them. So when you turn it, you'll hear a growling noise, and that of course is the bearings. Bearings would give a lot of trouble in alternators. It's very, very common, especially if somebody has fitted a fan belt and it's been over tensioned. It can put strain on the bearings, especially this front bearing here where the pulley is. So a growling noise, and they are quite easy to fix. So you just take them apart, replace the bearings, put them back together, and you're good to go. The other thing to mention, I suppose, is the charging. So if it's not charging at all, so we have to obviously then strip it down to investigate why it's not charging and the systems inside that can cause it not to charge. But before we do anything, if we have one that is not charging, the first thing we would do would be to check our electrical system off the alternator. So make sure that this is our battery positive connection, so this is the lead that will go straight directly back to our battery to charge the battery itself. And then the depending on what machine you have or what car it is, the electrical inputs into the alternator itself are very important. So if you look at this one, I don't know if it'll focus on that, we've got 3 connections here, but on this machine only one of them was been used. So the very middle one, so that is the feed from the ignition. So it runs from the ignition through the bulb down to feed the power coming into the system to activate the magnetic field inside in the rotor inside in the alternator. So once you have an ignition feed coming in and this end is good and you still have no charge, well then you know you've got a problem inside in the alternator. Now you have 3 connections here. Some would have a direct ignition feed, some would have a separate feed then to the bulb, and some would have a feed maybe out to a control unit or something else. But on this particular machine you only had one wire, very simple, one wire coming from the ignition, went through the bulb then that's obviously your battery warning light on the dash. So when you switch on the ignition, your battery warning light is illuminated because the system isn't charging. You've got potential difference between your ignition switch and your alternator, and that's going to switch on the light. When it fires up, when it starts rotating, your battery light goes out because you have no potential difference between your ignition switch, your bulb, and the system here. So the light will not illuminate. And so that's how we know we're charging. So after that, the next thing to do is to start stripping it down. So obviously we've got a couple of screws here on the plate on the back. So we'll just get the Milwaukee here, strip them off. Obviously, what I always say to people before they start stripping anything down, especially if you're not familiar with it, just index, a little index mark, because you do have alternators with different brackets that will go on in different positions. This one is very hard to get wrong, but you will get them that they will go on wrong, and then when you go to fit them onto the machine they actually won't fit on because the housings are on differently. Okay, so we'll just arrange everything nice and neatly. I'll be able to get them again in the future. So it comes off. So the first thing we want to look in here is for a buildup of dust, because it obviously depends on the conditions that the machine has been working in. So if you get a machine that's working in a dusty condition, dusty environment, maybe it's in a timber yard. I often find ones operating around timber yards, obviously to get a lot of sawdust, dust inside in the alternator, and they will fail prematurely. So take the cover and make sure before it's put back on that obviously it is cleaned. So that one is decent enough. So when we look inside here, what have we got? So the one thing to note about alternators is they're called an alternator because what they do is they create an alternating current. Yes, but Alan, does a car not have a direct current system? Yes, it does. All vehicles have, pretty much all vehicles, yeah, have a DC system in the body electrics, so DC current. So the alternator charges alternating current, so it produces alternating current. So we need some way to turn that into a direct current. So what we use is what's called a rectifier. So inside in the rectifier we have a system of diodes, diodes being a one-way valve, and if you look at the graph, look at the wave of alternating current being produced. If we put it's three-phase current, if we have the diode placed in the correct position, what we can do is rectify that alternating current to a direct current. Here's our brushes. So on this one, the brush pack is just separately, so we'll just take out the screws, we'll lift them up out of it. Now, as with our starter motor, the first thing we want to check is that there's a good length to them, there's a good strong spring to them, that they're not sticking, that they're not pitted or grooved, that they're not hitting the you know, the contacts in an irregular position, or, you know, created a big groove down into the shaft, which they haven't, because I know on this machine this alternator has been working fine. It was only swapped out for a bigger alternator with a higher output because there was extra equipment fitted onto it. So that's the first thing we want to look at. We want to look at our brush pack. So the brush pack obviously here gets its power from here, so it's coming from the ignition switch on the center, coming through out to that contact there, that point there, onto here, grounded through here, and that's where the power comes through for our brush pack. So that's the first thing we want to look at, is our brushes. They are very, very important, and they would be very, very common for the brushes to give trouble and stick with dust especially, and crap, and get, you know, pitted and grooved, not making good contact. So they're fine, we know they're okay. So moving on then, the next thing we want to look at is this unit here, which is our voltage regulator. Now, there's not a lot we can do with this. There's nothing we can physically look at. Chances are, if everything else is okay, you've got an issue with your regulator. Sometimes it can be overcharging or undercharging. Obviously here there's little heat sinks on it. You can do a resistance check at the back here just to see what your resistance through the system is. That will give you, you know, if you had the specs on it, you'd have an idea of whether there's an issue with it. But that is the voltage regulator. They would be common-ish. They wouldn't be overly common, but they are an issue that give trouble. And of course you can buy all these separately. Just take out the screws and bolt them into it. Very, very easy to do anything with these alternators, because everything does come separately. Everything does just literally bolt in and out of it. So that is your regulator. Obviously what it'll do is it'll just keep shutting off the power down into your brush pack to regulate the output of the voltage. So now it is important to remember that while you might have 14, you know, a good 14 volts output, you do need to make sure that your ampage, you know, the ampage that the alternator is putting out is correct and to spec. Obviously the easiest way to do that is with an amp clamp or a multimeter when the alternator is running. Moving on down into it then, the next one, I have all the screws taken out of this. So the next item to look at is our, so that's our rectifier there, that's our diode pack. So we've got all our diodes in here. And remember what a diode is. It is an electrical one-way valve. We've got 4 connections on this one, so you'd have, you know, for 3 phases, and then an earth as well for the system. And it is connected directly down into our field windings. So they would, you know, they'd give a little bit of trouble, all right. They wouldn't be that common because they are a fairly robust unit. They wouldn't give that much trouble. But that is it. That's your rectifier, and it will convert your alternating current that's coming out of your alternator down into DC current out through your output that is needed for the system that we've got on the vehicle, the particular vehicle. So we'll move on down a little bit further and see what else we've got. So having taken our 4 small screws out that hold the casing on, we can now pull the alternator apart. So we're basically just taking off, splitting the casings in half. So the first thing, we'll have a look at this side. So the first thing we have here, we'll look at is our bearing. So our bearing is down in there in the center, if you can see. So this is on the pulley side, taking the pulley off. This is our bearing down in here. And you can see that. Yeah, so that's the first thing that we're going to look at. If you have a noisy one, we can take the screws off on the plate on the inside. So having taken the bearing out, basically all I done was took the plate off the inside, put a socket on the other side, tap the bearing through, and all we can see is that's a standard seal 609 bearing. So, you know, if you have one with a noise in it, with a growl in it, they are very, very easy to change. And they are something that, you know, I'd keep on the van regularly, you know, for doing things like this. They are a simple little bearing. They just tap in and out of the housing, put it back together, job done. Because, you know, when you see what some places charge to, you know, what they call recondition an alternator, stick a bearing into it, and they might charge you 150 quid. It's well worth, you know, just a little bit of time, a little bit of patience, a little bit of know-how, and they're very, very easily done. So that is our bearing. So then we have what's called our field windings. So what the field windings do is similar to the story on our starter motor. So we have our rotor here. So as we said, the power comes in to the slip rings on the end of our rotor shaft. You can see there. Power is sent through, and we create a strong magnetic field inside in this rotor. So we've got a magnetic field built up. When we power there, this is one big strong magnet. You'll see in the back of it here, it has a fan to help with cooling, so it'll draw air through the system to keep the alternator cool. So we've got a lot of magnetism going on here, a lot of heat going on, and what will happen is, you know, through magnetic induction, you know, thanks to Mr. Faraday, who discovered magnetic induction. When we pass a wire through the magnetic field, a current is induced into that wire, into that field here, and it'll be induced, creating a voltage, output voltage and current at AC. So we have your AC current coming out. And that's as simple as that. That's as difficult or as hard as it gets. You can get these rewound. This would be a reasonably cheap alternator, or wouldn't be overly expensive. So whether you'd go to the bother of getting one of these rewound, you'd probably just replace it. They don't generally give much trouble, unless the only thing that will happen is if the bearing goes and they get hot, if it runs out of sync, it will create a lot of heat in here, a lot of burning, a lot of scoring, and you could possibly burn out your field windings. Again, how do you test them? You can test them with a multimeter, test for continuity, look for breaks within the system. They obviously, they can be, you know, there's different ways of winding, so they can be star wound or delta wound depending on the system. It doesn't really make a whole lot of difference, but the output, the outcome is the same, as the fella says. So yeah, there's not a lot more you can do with them. That's really it. You can obviously unbolt these and take the field windings out and have a closer look. So having taken our last element out, that is our rotor and our shaft with our slip rings that our brush pack sits onto. That's basically it. So you'll just notice there is another bearing at the back, albeit it's a much smaller bearing. I think it is standard, I think it's a 363 bearing. You would need a puller then to take that off if you do need to replace it. It would be unusual for the back bearing to go, because there's not much pressure. There's not as much pressure on the back bearing as there would be on the front bearing, obviously with the belt, the drive belt on it. So that is basically it. That is your alternator in a nutshell. So our rotor is our magnet, or basically our magnet that's fed in here, creating the magnetic field with inside in the rotor. It spins, driven by the belt. Through electromagnetic force, it's induced into these windings, and from that it's fed out through our diode pack, and from there down to our battery through that one there. And that's basically it. And the system, it's regulated obviously by, you know, the output is regulated by our regulator, which will cut in and out the power going to the field windings, to the rotor. So that will determine, it'll keep it, you know, charging in around 14 and a half volts. That's basically the system in a nutshell. That's how it works. It's as simple as that. Brush pack, obviously. So there are the things that can go wrong. There's nothing much more that I can say. A very, very simple system, simple to work on, simple to diagnose. A lot of times these days people will just if they have a problem with an alternator, they won't bother stripping them down. They'll just chuck them away. But I do know that this alternator alone, the dealer who supplied the machine wanted €700 for the alternator, but it's not a €700 alternator. That's what dealers will do. No, it didn't come off a John Deere. So yeah, that's it in a nutshell. They can be replaced very, very cheaply. First thing to look at is the brush pack. Obviously then our slip rings, our regulator, diode pack, windings. Highly unusual, that will go wrong with them. Highly unusual, that goes wrong with that. It's almost always down to either the brush pack or the voltage regulator, or possibly your diode pack. It is a possibility, but it is unusual. So that is it. Bearings obviously as well. That's it. Stripping them down, how they work, and you know what can be done to repair them. They are cheap repair if you're anyway mechanically minded whatsoever. So that is it. That's it for today. Just a quick little video. Obviously the dynamo that we would see on a lot of our vintage machinery is a different system. It operates, the operating principles are the very, very same. And dynamo is just a generator. However, you know, as most of you would be familiar with, the regulation end of it would be separate. So it would have an external regulator that would regulate and control the voltage output. Usually a small box mounted someplace within the cab, possibly, or around the battery area. Maybe I will take a look at a dynamo someday, but the operating principles are the very same, pretty much. Just that, you know, it's not all integrated into one tiny little package. It is worth remembering that the alternator itself, what its function is, is to, you know, take mechanical energy and turn it into electrical energy. Whereas with our starter motor, it was the opposite. So the starter motor would take electrical energy and turn it into mechanical energy, and then our battery would take chemical energy and turn it into electrical energy. So if someone asks what's the function of an alternator, that's the function. The function is to you know, take that mechanical energy from the running engine, turn it into electrical energy. Primary principle is to run all the electrics on the vehicle and to charge the battery. So it would be, you know, keeping the battery topped up when it is when the engine is running, but it would also be running all the electrical systems on the car. So when the vehicle, tractor, whatever it is, when the engine is running, the battery would have little or nothing to do with the power supply side of it. It is down to the alternator to do all that work. And as I said, on more modern machinery where you have a lot of electrical consumers, a lot of solenoids, a lot of lights, air conditioning, all that kind of stuff, fans, blower motors, radios, everything is all operated by the alternator, controlled by the power company alternator. You know, and it's not uncommon to see alternators of over 200 amp output. So it is important to make sure that the output is right, the voltage is right, and that the alternator is kept in a good, clean condition. Because they do like to suck in a lot of dust and dirt. So that's it. I'm going to leave it there for now. Thank you very much for watching. As always, any comments, please drop them into the comment section. If you've stripped an alternator, if you've worked on an alternator, if you've taken one off an anger and threw it across a hedge, yeah, please get in touch and drop us a comment. If you like the video, give it a thumbs up and a share. Until next week, I'll talk to everyone very soon. Thanks.